Okay, let's look at the free response questions now in Chem 11 sample exam 1. So the first free response questions, it's giving you a reaction and it says to write the balance equation. So in this case, we have two B's on the left, we have one B on the right, so we put 2 right here. That would cause us to have 6F on the right side, 2 times 3, so that means we need to have 6 HF here to make up 6F. And so the other thing that's left, of course, is the H and the O. Both of them have to be balanced with H2O. That exactly works out with a coefficient of 3 for H2O, so that's our balance equation. Now we're going to take a look at the limiting reactant. So that one we're going to do a little calculation. So the masses here is 14.15 grams of this guy. And then HF, we got a volume of 20 milliliter, but we're given density as well, 0.959 grams per mil. Remember that limiting reactant, a couple of steps there to figure it out. First is got number of moles of each of the reactant, and then divide by coefficient of the reactant to get number of reaction that you're going to run, and then the smaller number of reaction is limiting reactant. So let's figure out number of moles of B2O3. That's going to be 14.15 grams divided by the molar mass. You're going to go to your periodic table here on the left is 70 grams per mole, 0.20214 mole. And then you do the same thing for your HF. You have to first convert it to mass because they give you density and volume. So 20 milliliter times the density, which is 0.959 grams per milliliter. Milliliter cancel out. That gives you just the mass. And then from there you can divide by the molar mass of HF. This is 20 grams per mole. And so you end up getting 0.959 mole. So now that we have our number of moles, then we need to divide by the coefficient of each of those guys. So in this case, the coefficient of B2O3 is just 1. Remember that 1 really stands for 1 mole per reaction. For the HF, you're going to need 6 moles per reaction. And then so what you want to do is find out what these numbers are. So this one's not going to change, so 20214. Reaction now. So that's how many reactions you're going to be able to run. The other one would be 0.1598 reaction. This is a smaller number, so your limiting reactant is going to be HF. All right, so now let's go to number C. And that one is asking how many liters of H2O is produced if the density of H2O at that temperature is 0.997 grams per mil. Because you want a liter in the end, so you want to figure out volume. Volume you can find from mass divided by density. Mass you can get from stoichiometry. So to do that, remember you're going to use your limiting reactant, which is HF, remember? And the number you're going to use is not the red number here. You want to use this number right here, okay, as your starting number to calculate, because that's the actual number of moles of your HF. And then you multiply this by the relationship between HF and H2O, your mole-to-mole ratio or your stoichiometric relationship. Go back to balance equation. We find that that's 3/6. And then to convert that to mass, we're going to need the molar mass, which is 18 grams H2O per mole of H2O. Right? Our answer here, 8.631 grams of H2O. So volume is going to be equal to mass, which is this number, H2O, right, over the density of H2O, which was 0.997 grams per mil. You get pretty much the same number. They want the answer in liters, so you just have to convert that to liter. So basically, it's going to be 8.657 times 10 to the minus 3 liter. You notice that all the numbers that was given to you earlier, they all have 4 sig figs, so the final answer should be 4 sig fig as well. The last question, we want to know how much of this guy is being produced, the BF3, if you got percent yield of BF3 being 81%. So let's work that out. The first thing is just to kind of figure out what the theoretical yield would be of BF3. So we'll calculate our mass of BF3, and this is our limiting reactant, right, HF. So that's going to be multiplied with now the mole ratio or the stoichiometric relationship between HF and BF3, and we look up our equation earlier, would be 2:6. And then we got to find the molar mass of BF3 is 68. Okay, so then the mass here is 21.37333 grams. And then what they're asking us is volume. The volume is going to be mass over density. So 21.3733 grams. Density, we were told, is 2.84 times 10 to the minus 3 grams per mil. You're going to get 7653.99 milliliter. Now, that would be the theoretical yield in volume of your BF3 gas, but it says here in the question that the percent yield is only 81%. To get the final volume, you're going to have to take this and multiply that by 81%, which you end up getting is 6199.7 milliliter, or we can write it in scientific notation. It'll be 6.200 times 10 to the third milliliter. All right, so that would be in 4 sig figs answer.